Today we're talking about time series forecasting, and this is one of those techniques which is used very, very widely wherever there is time series data involved, like forecasting, financial sector, stock market analysis, marketing data, advertising data, all these types of data where you are dealing with daily data or monthly data. Time series forecasting is really going to be invaluable for the business. So in today's video, we are going to just create a small synthetic data out of it and then learn how to use ARIMA modeling on it, which is one of those really popular forecasting techniques. So I have these two modules, libraries that I want to import, and I'll set a random seed, and we are just going to generate this synthetic data that I have here. And let me print this out and we'll check it out, how it looks like. So this is a daily data that we have, and we are just bringing in some sales data along with it, which is all just made up synthetic data. So this is good, but let's visualize it. This is one of the first steps that you would do as a data scientist. So for that, I'm going to bring in Plotly or Matplotlib, and either of these two code works, but let me just plot this in Plotly for now. So we'll initialize a figure. To that, we are just going to give it the option of a line chart, which is what we want to plot, time against sales. And we're giving it the X is my data and Y is my sales and the title. So that's good. And we'll just update the layout with proper access titles, because we want something that is easily readable and that can be shared to other people. And finally, we'll do a figure.show. Now, when I do figure.show, I get this sort of a plot over here, which is a Plotly plot. And if I hover my mouse over it, I can see all the dates and the values. And I have made it so that this synthetic data is kind of like an on and uptrend, so that it's easy for us to build a ARIMA model. And also it kind of depicts the real world scenario as well. So this is the complete synthetic data that we have from January till March. So now is the good time where we want to bring in the ARIMA model and see how it all works. And I'm going to explain or try to give you an intuition of how ARIMA works, but let's just run this for a second. So I'll just bring these two libraries in, and we also want the sklearn's mean absolute error and mean squared error. And we're just going to split our data into training set and test set, so that in the end, we're able to kind of look back at the data that we had, like let's say the past few days, and then compare it against what we predicted to get the accuracy score. So I'll just say my training size is 80% of the data set, and we'll use train and tested split. And finally, we have this ARIMA model over here. And the most important thing over here is, of course, we are providing it the training data, but we are also giving it an order of 511. And this is one of those key pieces of information that you would probably do again and again when you're trying to model or do a hyperparameter optimization, right? So for now, it just says order 511, and we can hover our mouse over it and then see what it actually means. So the order is actually coming from this integration model over here, where we're giving it P, D, and Q, which we can see here. The order is P, D, Q, and this represents autoregressive differentiates and moving average components. So let's break that down for a second before we move on, because this is quite important. So the first component is P, which is autoregressive. So for example, take temperature today, and if you wanted to forecast temperature for the next day or the next 3 or 4 days, then the P term is what you're going to use to look back on how many days that you want to look at to predict the next day. So if it was 1, then you would just look at temperature yesterday to predict today's temperature. Or if you had this value at 2 or 5, let's say, then you would look at the past 5 days data to predict the next day's data. So this is autoregressive part. Next, we have the differences or the integrated part, which just means that if, for example, if you're tracking your grocery spend over time, then there is obviously a trend associated to it because of inflation. So it probably keeps going up and up. But we really want to take this seasonal component out of this model that we're building, and we want to make it stationary. So this differences model, what it does is we are just giving it a value so that it removes that seasonal component, and then it just gives like a stationary plot for us. Then finally, we have the Q, which is also a moving average. So for example, if the past 2 days, the temperature were really high, then there is a good probability that the next day's temperature is going to slightly reduce. Maybe it's going to rain, who knows? But yeah, if you want to capture all of these kind of trends, then you would add in some moving average component. And for now, we are just going to set some random number, 511. That's fine for us. And let me just run that. And we are going to call model.fit on it. And then once we've done the model.fit, we can forecast the test data set. And here, just giving it length of test. So if I just look at how many days that is, is. It says that we are forecasting the next 20 days over here, and we'll just run this, and this is stored in our prediction variable. And finally, we can calculate the evaluation metrics, RMSE and MAE. So let's just run all these. Then these are going to be standard, right? So whenever you're calculating some forecasting or some, if you want to calculate this accuracy, then you'd probably want to go with some of these metrics. And we see here absolute error is 25 and root mean square error is 27. So those are the kind of metrics that we get, but we really want to see something visual because that's where you can understand what's happening with this data set. So let's just forecast in the next few days, let's say 10 days, and I'm just going to plot this out. And we see here, this is the observed data, but then if you see the forecasted data, it's somewhere over here. So obviously the model.fit did not do a good job, or maybe the PDQ terms that we defined for ARIMA was not good enough, right? So this is somewhere over here, and obviously this is going to be a drastic change for the sales forecast, and we can't really go with this. So let's do some model tuning, also known as hyperparameter tuning. So we really want to find out that optimal PD and Q values, which is going to give us a really better value than what we're already achieving. So if I come to the model tuning section, I'm just going to import a few more libraries, and we're just going to define our PDQ range, so which can be from 0 to 5, and this is good for us. And we're just going to create a triplet of this PD and Q, and let me just show you what we have here. So it's just going from 0, 0, 0, 0, 0, 1. So it's creating this permutation of different combinations of these PD and Q values, and we have a lot of them. So we're just going to run through all of this and see where we get the optimal model. And we're going to store the mean absolute error in this. So we're just going to initialize a data frame, which just looks like an empty data frame like that. So that's fine. And then here we are doing a grid search where we are just doing a simple for loop over this PD and Q, and we take each of those params and then pass it to our ARIMA model, look at our MAE and predictions, and just add all that into our results data frame. So let's just run through this. And now if I just print this out, where we want to print the best results that we got. So if we say results were empty, then of course we did not find anything that resembled like a good model for our ARIMA. But let's hope we do have some values in the best results where we're just looking for the minimum of MAE. And if I just run this, so we do have an ARIMA parameter called 424. So these are PD and Q values, and this gives us the best MAE. So if you remember in the past, we had like 25 or something for MAE, but after this hyperparameter tuning, we have come down to 5.6. So hopefully this is really good. So we're just going to pass that best para PDQ into our ARIMA model again, and let's try to fit this and see if this plot improves a bit. So now if I run through these commands and plot this again, so we do see some forecast which has gone up over here. So if I look at the previous plot, so this was all the way down here, which doesn't make any sense because the trend is up there and the data is there. But now this is for the optimized version that we just did, and this is somewhat in the range over here. But again, you probably want to do a lot more over here with additional hyperparameter tuning, different kind of models that you want to use for forecasting, etc. But this gives you a small introduction into how to use ARIMA modeling in your forecasting exercises. And further down in the next few lessons, we'll also look at other libraries, which is like Prophet and other libraries, which are really good at doing these things for us.